Welcome to the Runge-Kutta method in Excel. So as I mentioned in the previous video, I have most of the formulas plugged in for the Runge-Kutta method. You can see our xi, yi. You can see our series of points. It looks like I actually labeled my numbers and i's in the reverse order here. But we have our point 2, 3, and 4. So here's point 2, point 3, and point 4. And then we have the slope from our initial point, second point, third point, 4 point, and then this will be that overall average slope. So we here are going to work with the same problem we've been working with previously. So we'll go ahead and consider the IVP y prime plus 2y is equal to 3x squared times e to the negative 2x with y of 0 equaling 2. And our job is going to be to approximate y of 0.5. So same problem we've been looking at all along. So what we need to do, we have to start with entering our initial conditions. So we're going to do, we have initial condition x is 0 and y is 2. And we need to enter in our equation. So here the B column is acting as my y, the A column is acting as my x. The reworked equation is y prime equals negative 2y plus 3x squared times e to the negative 2x. So we are going to work with that reworked equation. So we need a negative 2 times y, which we already have, plus 3 times x squared. And then we need to multiply by the exponential function with exponent negative 2 times x. So that one's set, and we can just hit enter. Same thing for K2. We have to make sure we have the correct formula. This time the D column is our x, E column is our y. So we need plus 3 times. And then we have x squared times the exponential function raised to the negative 2x. Once again, same formula. This time we're using G as our x column and H as our y column. So we just need to add in the 3 times and change that exponent to a squared. And then we'll do the same thing for K4. So this time J column is acting as x and K is acting as our y. So we need to change this to a 3 times J13 squared. Everything else looks correct. Whoops. Oops, that should be a 3, not an E. Here we go. Okay. Now at this point, it doesn't know what my step is, and it doesn't know how to calculate the next y value. So we need to plug in those 2 pieces of information. So plugging in those 2 pieces of information, I'm going to plug in my step by hitting equal, click the previous x value, and then put your step. So let's do first for step 0.1. Hit enter. For the y value, we have this y value. Sorry about that. I didn't want to actually type y. We have equals the previous y value plus our k is our slope, and then times again. So I don't have to change the step twice. I just like to do xi plus 1 minus xi. So that's A14 minus A13. Hit enter. At this point, we can just drag down. So click in a cell and drag. Click in the bottom cell and drag. If we want, we can just highlight all of these in one go. Click in the bottom cell and drag. The last row doesn't work because the formula did use a xi plus 1 minus xi. Let me move my, there we go. So here we have our, at 0.5, we have our y value is 0.7817, which is very, very close to the actual y value of our solution curve. So when solving with Runge-Kutta, just using step 0.1, we got very close to the actual solutions. The actual solution, we had, let me look it up. The actual solution, I had only written out the first 4 decimal digits, but it was 0.7817 ... So in this case, just using step 0.1, we're already essentially matching our actual solution. So Runge-Kutta is more complicated to use, but is much more accurate, and is therefore what most places now use for their numerical approximation.